All right, in 14, we're looking at the following subset of C. And all we want to know is, well, first of all, what is this set? And is it open? Is it closed? Is it neither? Is it bounded? Perhaps, maybe? Is it connected? So the words we introduce in this section, do they apply? How do they apply to this set? Do they satisfy the definition? And so on. So whenever you're asking questions about a set like this, or any set, it's good to have an idea of what it looks like. If we think back to the videos on the material, we know that this is a strict inequality, and usually this tells us that our set is open. Okay, but it's best to have a picture so that we can reference that to actually see that it's open, to see that there's no boundary on our set. So let's first figure out what in the world this means. Modulus of the real, or in this case, since the real part's a real number, this is absolute value of the real part. It's bigger than 2. So absolute value of the real part of z is bigger than 2. The way in which we can get an idea of what this looks like, of course, is to go to Cartesian coordinates. So we're going to do that. So the real part of z is x. So this is the same thing as saying the absolute value of x is bigger than 2, which is the same thing as saying x is less than negative 2 or x is bigger than 2. Those are all the real numbers that have absolute value bigger than 2. So if we were to try to graph this set, real part of z, sorry, absolute value of the real part of c is bigger than 2, our real part, which is x, has to exceed 2, so let's mark 2, or it has to be less than negative 2. So let's mark negative 2. We'll go out to 3 in each direction. So here's 2, here's negative 2. We're not allowed to be equal to 2 or negative 2, right? So all points in the plane where the x-coordinate exceeds 2 is going to be to the right of this dotted line. So this guy here is the collection where the real part of z is bigger than 2. Again, that's x. And then on the left-hand side, we actually have another dotted line. And to be less than negative 2, for the x value to be less than negative 2, you have to be to the left of that line. So this is all points where the real part of z is less than negative 2. And again, x is the real part of z. So that's our set. It's like the complement of a vertical closed strip. But we can see in particular that this set doesn't have its boundary line. In particular, there's a dotted line here. So this one, if we were to go through the conditions, let's pick a different color. Let's use this magenta. This is open. Is it closed? No, because we're missing our boundary points. So it's not closed. And in general, for almost all subsets, if you're open, you're not closed. There's some technical stuff with that we're not going to get into, but if you're open, you're not closed. So this is kind of redundant in this case. Is it neither? Well, no, it's one of them, so I'm not going to put anything there. Is it bounded? So can we run away to infinity in either of these sets? Yes, we can, right? We can just go to 3 and then 4 and then 5 and then 6 and then 7, and we can just keep going to the right, or we could go out on a ray, for example. So it's not bounded or it's unbounded because we can run away to infinity. Is it connected? Well, I see two connected components, two pieces, and they're separated by this channel. So this is also not connected.